So the team with us today is from L&L Products. It's a local company. They do all kinds of cool stuff. It does involve chemistry from time to time, which is why they're kind of here with us today, talking about some product line that they kind of work with. They're going to talk to us about some of the chemistry that's involved with it. They're going to talk about maybe how you guys could be involved in that process as well if you're looking to do some extra stuff with them. So please keep an open mind to that. We obviously do have a little bit of camera work going on today, so we can kind of like demonstrate this or show it and have it documented. Just in the back of your minds as well, there's at least once or twice where they ask for a volunteer help, right? They're not asking for you to sign up for life, they just need someone to come help with the demo. So just please keep that in mind. Here. 2-second, 3-second kind of thing to come up with, right? It's really quick.
Welcome. This is 10th grade chemistry, I'm assuming? 10th grade chemistry? Well, I'm Steve Balsam. I'm the process engineering manager at L&L Products, and we have a group of people, and Laura is going to be here. She's going to introduce herself in a bit. Today, talking to different classes in your chemistry department, and we're kind of going to be talking a little bit about how you take education, a little bit of chemistry, into innovation, into science, into learning, and then apply it into entrepreneurship. And because we work for a company, L&L Products, and what we can do with that. So today we'll give a little introduction about L&L, working in R&D, research and development, talk about some chemistry, and Faster is a new product line. We have a new material technology that we're going to talk about, do some demos, and working with chemistry, and a little ask for you guys. So L&L Products. Anybody familiar with L&L Products if you came up or grew up in the area? Anybody familiar with L&L Products? Maybe a few have heard of it. Two guys met in high school, Almont High School, but they met and they formed a little company. It started with some chemistry, and now it's a global operation, still privately held. They've passed on, but their family, third generation, it's a family-owned company, started in 1958, and now it's in a global company. And there's approximately 1,500 employees worldwide, 500 here in the U.S. Romeo, and we have manufacturing in Romeo, Michigan, in South Carolina, in Brazil, India, France, Turkey, China, Singapore, and India, yeah. I think is the ones we caught. So started right here in the backyard, in the kitchen. So to start with, we have different technologies. And chemistry started out in the sealing industry, kind of, but we are in different types of technologies. We say a technology, it's a type of chemistry and how we're solving problems. So it might be in reinforcement, where we're trying to make something stronger. It might be in acoustic, making something quieter. It might be in sealing for emissions or noise. Might be thermal or bonding for strength of gluing something together, an adhesive or something like that. Today, we're going to focus on the stars, the yellow stars. This is our Faster technology, where it can be used. It's a new thing for us, launching, and it's in various, it's in several of the areas, and we're going to be talking about solving some of those problems in those areas and where it can be used. So before I pass it on, I'd like to touch on our values. So at L&L Products, this is our mission statement: to be a good place for all who touch it, where quality of work, product, and relationships are a priority. So these are the 8 values we have, and we use them every day in our work every day. What we're talking about today, we're going to focus on 2. We're going to talk about that creativity, that innovation, and that entrepreneurial spirit, and being a good citizen in the community in this connection with the school. You had a question? Yeah.
I don't know if I missed it, but what is
L&L Products? Great question. L&L Products, it's the 2 last names, Ligon and Lane, that started the company. So that's simple. And they made products, and they kept it very simple and grew it into something. So with that, I'd like to introduce Laura. So
Thanks.
Go ahead.
Okay. So my name is Laura, and I work in the Research and Development Department at L&L Products, and I want to talk to you a little bit about what it's like working in the lab. And I'm going to compare it to baking bread. So when you bake bread, you use some primary ingredients. You need flour, water, yeast, and salt. But you can make all sorts of bread. So let's say you want to make a cinnamon raisin bread. You're going to add cinnamon and raisins. You can add different types of sugars. Maybe you're going to add molasses or brown sugar, honey. If you want to make a focaccia bread, you're going to add herbs and garlic. You might add cheese, nuts. There's all sorts of things you can work with to make bread. Well, formulating products that we sell to customers is a lot like that, only we're using ingredients that are chemicals, things that aren't generally found in your kitchen. And how much you add of those ingredients, the recipe or the formula that you use, is really important that you follow it. So here in this example, we have bread made with 0 salt, 2% salt, and 10% salt. In the 0 salt example, you can see the cell structure is so big that if you were to put jelly or something on it, it's going to seep right through to your hands. It's kind of messy. If you put 10% salt in there, you probably have killed the yeast, and so it wasn't able to produce gas and it didn't bake and have a nice airy structure. Another thing that's important, both in baking bread and in working with our products, is how you process it. So the order that you add the ingredients, how you mix it, how long you mix it for, the temperature you mix it is all very important. And this is another example of bread that was needed too long, not needed enough, and needed the right amount. So there is probably a research and development lab at Aunt Millie's. You've maybe seen like America's Test Kitchen, where they try all different things, right, to find the best final recipe. We're kind of doing that same thing at L&L. So at Aunt Millie's, they might say, hey, we want to make a vegan bread, a bread that doesn't contain any animal products. So no eggs, no milk, no butter. But that bread should look the same as regular bread, taste the same as regular bread, and probably it could stand to cost a little bit more, but it shouldn't be double the cost of bread. And so there's someone at Aunt Millie's running experiments, mixing those materials, and trying to find a replacement for all of the animal products in there. Here's just another example of an experiment somebody ran and analyzing the results of the cell structure and the height of the bread with different additives in there. So this next slide, it's a little overwhelming, but I just want to explain to you that we're not using kitchen ingredients. We are using all sorts of chemicals. One thing we're using is polymers. Polymers are these long chain materials, kind of like this, a long chain of different things connected together that really helps bind our products together. Kind of like an egg does in batter. It's the binder that holds all of the solids and liquids together. We're using curing agents and accelerators. We're using foaming agents. Foaming agents in bread generally are baking soda or yeast. We're using baking soda, something very similar to baking soda in our formulas. We're also using something called azodicarbonamide. It's this structure here. Interesting that this is something that bread makers do use. It's a non-natural ingredient. So if you look at some of the ingredient list in bread that you can buy at the store, instead of saying yeast, it might say azodicarbonamide. I find that really gross, having worked with it in the lab, that it's a chemical. It's okay to eat, but I would rather have something more natural than something that contains this chemical in my bread. We're also using something called Kevlar pulp. If you were to magnify this, you would see it's all these little fibers that make up this pulp, and it's very strong. It's very resistant to flow. It's very resistant to impact. And we add that to our materials to make an impact-resistant material. We add adhesion promoters, things to help our materials stick. We add viscosity modifiers, things to make it flow or make it not flow, and all sorts of other ingredients. And one of the fun things when you first start working in the lab is playing with pigments. You get to pick the color that you want your batch to be. You get to see what happens if I put a little bit of orange and a little bit of green. That usually ends up looking kind of like puke, but you can play around with pigment colors. And in bread, cocoa powder is an example of something that will change the color of your bread. So in the research lab, I am using the scientific method every day, all day, over and over. We make an observation. we ask a question, we form a hypothesis, we experiment. Experiment really means picking ingredients that we have access to in our lab or looking outside of our lab and finding new ingredients. Trying to understand what they do in the formula, so we put them in a batch, we mix them together. I make samples, I cure them, and then we analyze it. Analyzing it is generally done in our mechanical testing lab, where we are crushing things between two plates, seeing how much strength it can hold before it crumbles and falls apart. We're pulling things in two directions to see how long it can stretch before it breaks. We're testing things in shear, which is the force of something sliding back and forth. If I take this stack of papers, sliding this back and forth like this is shear strength. We're measuring its resistance to shear. So we're doing most of these tests sitting at a computer, kind of destroying our samples. We gather those results and we try to make a conclusion on what the effects of the ingredients were in that formula, and did it meet all the things we wanted it to do? Almost never. So then we make a new formula, we apply what we've learned, and we try again. So one question we asked at L&L is, can we make a better product than the adhesive labeled as the world's strongest bond? That is Gorilla Glue. Gorilla Glue has on their package world's strongest bond with a very small overlap of two metals glued together. You can hold the weight of a cow with this bond. It is extremely strong. It is extremely strong in shear, that force that I showed you that's sliding back and forth. So we want to make something better. So first we brought that adhesive into our lab and we did all of our tests on it. What does it bond to? We checked wood, we checked leather, we checked different types of metals, we checked concrete, we checked porcelain, glass. We wanted to know where isn't it functioning? And we wanted to make sure our product was going to bond to all the things that Gorilla Glue couldn't. How does it smell? So a lot of the adhesives you buy at Home Depot have an ingredient in there that's sulfur. Sulfur is one of the elements on your periodic table. It smells like sewer. It's a relatively safe ingredient in these adhesives, but as soon as you open it, that's right, Steve, you found it?
Which one is it?
It's S16.
Help me. 16. Thank you.
And it really smells disgusting. And so, you know, when we use it in our lab, everybody's like, who's using the mercaptan? That's the chemical that contains it. Everybody makes fun of the person who's opening up the package. So we don't want that in our product. We want to make an adhesive that doesn't have an offensive odor. How easy is it to use? Some of these adhesives that you buy are not simple. You can't just open the package and use it. You may do it wrong, and then if you do it wrong, you're not going to have a good bond. And what type of forces can it resist? And this is where L&L really made something that is better than the world's strongest bond. So I need a volunteer to come up and do an easy, fun experiment. You? That would be great. Thank you. Come on.
All right, come on up.
So this is a T-peel. I'm going to remind you that a shear force is the force kind of sliding back and forth in one direction. A peel is moving in an opposite, in a peel force. So if you have like Post-it notes, peeling a Post-it note off is a peel force. So I'm going to put these vice grips on here just so you have a way to hold on to it. So this is the world's strongest bond, and I want you to pull it apart like this. You might have to give it a little, there you go. So it broke apart pretty easily, right? This is not impressive. A lot of the forces of the things that you are going to pick, and you can stay here, are in peel. They're not just having one force on them. They might be being compressed or having tension or being in peel. So now this is our adhesive. We use this number and letter to name all of our products. There are so many of them. So this is AK700. This is how we distinguish this formula from other ones. Now do the same thing. Pull it apart. Peel, peel.
You can do it. Come on.
Chances are you can't do it.
Oh.
Yeah. You most likely are not going to be strong enough. Most people cannot break this apart. Thank you very much for your help. So I just wanted to show you that. Right. You want to try?
Yeah, I think someone else wants to try. Yeah, let's give it a try.
just be careful where your elbows will move if it
Yeah.
does break.
Yeah.
So don't let it hit anything.
But you kind of are seeing the connection between chemistry and properties, right? You have different types of properties. And then you have, here's a material science. We're talking science. Sometimes you can't argue with science. There's a great example, right? A different type of chemistry. Who would have thought? That says football team, right? Oh, who's your coach? Who's your coach? I'm just kidding. Okay.
So this is a chemistry class. We are going to introduce some chemistry concepts that are important to our faster material, which is what, later we're going to be asking you to work with. You're not going to need to know the chemistry to work with this product, but we just want to tell you, kind of what the chemistry we use to make it. So, acid-base reaction. Can someone tell me, have they ever mixed vinegar and baking soda together? Yes, what happened?
Bubbles.
Bubbles,
Yeah.
right. So carbon dioxide gas is produced. It bubbles, and then it kind of falls flat. And what falls flat in that liquid is water and sodium acetate, and the carbon dioxide is just released.
Does anybody know an example of another acid? Might be a common acid you might work with or know of? Mm-hmm. Anybody?
I heard somebody say.
Hydrogen peroxide.
Hydrogen peroxide, not quite an
Not
acid,
exactly.
but it's peroxide. Anybody with an acid? You even eat some, right? Citrus acid, right?
Yes.
That's a very simple. It's a natural acid, but those are examples.
Yep. So mixing vinegar and baking soda together is a very simple reaction. And you might think, what is it more than a kid's science experiment? Well, somebody thought of a way that they can use that science experiment to solve a problem. So they were creative. So I just want to show this video. So what this has here is a drain. This is what's beneath like your kitchen sink or your bathroom sink. It's clogged, probably with hair and grease and chicken parts and peanut butter. I don't know what else, but it's not draining, right? So if you put some liquid in here, you can see it stayed right there. You could use Drano. Drano, you're definitely gonna have to go to the store and buy. It costs money. It's a pretty nasty, caustic ingredient. You really don't want that going down the sewer. So she's put some baking soda in there. She's about to pour some vinegar in there, and she's gonna cap it with her left hand. So this carbon dioxide gas is building up pressure. Because it can't be exhausted through that port because she has a cap. She's gonna do it one more time. More carbon dioxide gas is going to be produced. Whoop. And the drain is unclogged.
Simple stuff you have available, right? Just knowing a little bit about science, knowing a little bit about chemistry, and you can solve a problem, right?
Back here. All right, a little more chemistry. So we have the chemical symbols that make up the ingredients that I just want to show you here. So vinegar is acetic acid, sodium bicarbonate is baking soda, and the products are sodium acetate, water, and carbon dioxide. All right, now in order for you to understand our faster products, I want to introduce to you the terms thermoplastic and thermoset. These terms describe polymers. Polymers are these long chains of material that differ in how they react to heat. Thermoplastics soften and melt when heated, and they can be reformed. So plastics that you put in your recycle bin are thermoplastics. Can anyone think of a thermoplastic that maybe they use every day or something in this room that could be a thermoplastic?
Melt it down, reform it.
Maybe you guys might have some thermoplastics in front of you.
It's like those look for like hand warmers.
Hand warmers.
So the hand warmers, like the metal, those have metal inside that when they're exposed to air are exothermic. They react with air and produce heat. So I'm talking about a plastic that you put in your recycle bin. It's melted down, probably ground up, melted down, and reformed. Water bottle.
Water
Yes.
bottle.
Water bottle, yep.
Go ahead. Water bottle.
Yeah.
I think of chocolate, right? You can melt it down
Yeah.
and reform it, right? It's a chemistry.
Absolutely.
Food is chemistry.
So there's a lot of examples. You know, these plastic lawn furniture, a lot of the buckets and pails you take to the beach. Most of these, you know, throwaway one-time use plastics are also thermoplastics. These are all things that are heated up, generally injection molded into a certain shape, cooled down, and that process can happen over and over again. So thermosets, on the other hand, sort of the opposite of a thermoplastic, cannot be heated to be reformed. Bread is an example of a thermoset. You put it in the toaster, it starts to char, get a little bit brown. You leave it in the toaster too long, it starts to really smoke and burn a little bit. You're breaking and destroying bonds. You're not just melting them. But cheese or chocolate, like Steve said, those things are thermoplastics. You can melt them down, put them in a different shape, let them cool, and they will harden and take on the new shape that you made. So I need to have 2 volunteers come up to do another easy experiment.
One over here, one over here. Someone come on up from over here.
I think my friend Miguel should go.
Yeah, we'll get someone from over here. Someone from over here,
White
come on
sweatshirt.
up.
All right,
Come on up.
thank you, thank you.
There are
There-
stuff.
Yeah, you're gonna get a prize.
You get
guys.
stuff from this.
So
Right.
these I am having represent polymers, okay? So these are these long paper clip chains. And if I mix them together,
Stand behind here. Just show
if I mix them together, I can still separate them out into these long chains again. So what I want you guys to do is to take red paper clips and connect these chains together in several spots. So connect this chain to this one and this one to this one, and do a few different of them.
Why red and white, Laura? What's
L&L Products colors.
and Romeo
and
Bulldogs,
Romeo
right?
Bulldogs, of
Yeah.
course.
What a combination.
So what these 2 boys up here are doing is they are creating what are called crosslinks. Lost my pointer. And crosslinks are what makes something a thermoset. These are bonds that are formed that create a network. And if you can connect this one to that one too.
You're doing the reacting. You're
Yeah,
doing the reacting,
that's
not
right.
acting. You're doing reacting right now. You're bonding things, bonding chemistry.
I'm gonna do this one first.
Sorry, I didn't finish. I'm taking a class right now.
A lot of pressure here, right? I said this was going to be easy. So also you can think of crosslinks that are a property of thermoset as like tying knots too. But these knots, they can't be untied without breaking the bond, without destroying the property of the material. This is great. Thank you guys. Did you get that last one on there? Okay. So now when I mix this whole thing together, it's interconnected. I am not going to be able to get this apart without breaking bonds, without destroying this thermoset. And this type of crosslinks and this chemistry is what makes our final faster material. Thank you guys very much. Appreciate it.
Okay. Thank you. Thank you. All right.
Great.
And is one better than the other? Well, just depends on the properties, right? Depends what you're trying to solve, what you're trying to create. Not necessarily one type of bond is better than the other. You may want it not to cross-link. Sometimes you want it. Sometimes you want to really cross-link it. All these are variables. You've got a big periodic table of elements. You start combining all these different things. This is science. This is the power of science and knowledge and knowing these things. You can take different aspects, put things together, and create all kinds of things. Material science is just, it's a growing technology. It's a growing just educational field. You know, it goes into chemistry, it goes into food science, it goes into pharmaceutical, you know, it goes into medical, cosmetics, you know, all this stuff is the same thing. Materials are changing the way we live and the way we work. So it's exciting to be a part of a class like this where you see science and you are engaging with science. It's going to make a big difference in your future and what you guys are thinking about and doing every day. even if it's not in your field of work. What you do every day, it's out there all the time. So.
Okay, we have a short video to introduce you to our faster products.
Here at L&L Products, we want our customers to think faster. Think faster? No. Let's not misunderstand. When I say think faster, that's faster with a PH. Our pH refers to adhesives and sealants that will enable and transform the way our customers solve problems. Hit them with the catchphrase, think faster. Let's get into it. Faster is a family of products consisting of a two-component foaming and non-foaming adhesive. I say two components because it indeed takes two. Sorry, couldn't help myself there. Let me try that again. It takes two different liquid components mixing together to actually create the product. You can see the example of the static mixer here. Both liquids combining together creates the chemical reaction that allows the product to foam up.
And I'll mention right now that this video was made by somebody who works at L&L Products. They're using some of our marketing pictures and some of the videos that we have that we've made. And they are using it to train both people internally at L&L and outside here like you guys. So it's an example of one of the many jobs that you can have. You know, we're a chemical company, but there are people who work there that work for IT, for purchasing, accounting, engineering, lots of different fields that, you know, are available to you at a company just a few miles away from here. All right, so we're going to review faster, and we're going to combine some of the things you learned about acids and bases and thermosets to talk about this product. So it's a two-part material, also called two-component or 2K. We use all these things sort of interchangeably. The reaction occurs at room temperature. So we don't need an oven like we do for bread to cure our product. It is the reaction of epoxy molecules. So epoxy molecules are this triangle-shaped molecule. This represents carbon, carbon, and oxygen. It's like a head and two shoulders. And a triangle-shaped molecule wants to react. It's unstable, so it wants to find a more stable form. To make a thermoset faster product, we have a chemical reaction between the epoxy molecules and acidic molecules. So we're not using acetic acid or vinegar. We're using something that's in Coca-Cola. Phosphoric acid is something in Coca-Cola, and we are using those acidic molecules to react with the epoxies. To make a faster product foam, so in the acid and baking soda example, baking soda is what reacted to produce carbon dioxide gas. We're using metal carbonates such as limestone. Another name for limestone is calcium carbonate. We're using that to produce gas. The resulting product is a cross-linked thermoset material. So everywhere you see this red circle is like the red paper clip. It shows a cross-link, and we use that cross-linking to trap the gas. And now I'm going to do some faster demonstrations for you. So I'm going to start passing these around. The first demonstration I'm going to do is going to result, and I will move over there when I do it. Okay. It's going to result in a hard, high modulus foam. It's our AK607. I'm not going to make this one, but that's an example of a soft, more flexible foam.
Similar chemistries,
So
just different
in
hardness, different
the
properties.
research and development lab,
Pass 'em
when
around.
we are working in the chemistry lab, we have to wear lab coats. So I'm going to put my lab
What's
coat on.
PPE? She's wearing PPE.
Wearing
What does
PPE.
PPE stand for? Personal. Who said that? I heard a few of those, you know.
Girl over here in the pink
Yeah.
sweatshirt.
All right. Good stuff.
I want to protect my clothing. I want to
was
protect
it?
my skin.
You say it? All right. Way to go.
And depending on the chemistry we're using, a lot of times we only have to wear, you know, I'm probably wearing this stuff 4 hours throughout the day. I have an office that I go in when I'm analyzing data, and so I don't need to wear this whole get up. So it's not something if you're like, oh, this looks uncomfortable. Yeah, you have a question?
Do you not get like those little like marks around your eyes?
I get them, and I get them bad. I have a very impressionable face, and so these glasses will leave the ring around my skin, but it goes away. Yeah. Not too tight, I think, is a key too. So in this container, and this one here that I'm holding in my left hand, is the epoxy containing side. But there's more in here than just epoxy. I have those fillers. I have things like the Kevlar fiber that I showed. I don't have any pigment in here, it's just the natural color. I have some calcium carbonate or limestone. This is what's going to produce the carbon dioxide gas. And in here, I have something containing phosphoric acid, but there's more in here than just that. There are things to help it so it doesn't flow very much. I don't want this material to be too runny. So I'm going to mix this 2-part material together, just using a tongue depressor. The reaction happens at room temperature, however, it's exothermic.
Can you put this camera
Oh,
on?
thanks.
Yeah, let's put the
Thank you very
camera
much.
on and,
Yes, I forgot.
Sorry.
Okay.
You got it?
Yep. He turned it on.
Everybody can see up here?
Thank you, guys,
So
for
you're
doing that.
mixing, is this both the A and the B or just the?
So the A is in the cup down here, and I'm adding B to it.
So what's going to happen? You got A and B, right? Epoxy and acid. What's going to happen? You can't talk about it. Some type of cross-linking, right? Some type of reaction. Something's going to happen. I don't know what it is, but just mixing it up
All
right
right,
now.
so I need to mix it well because I want all of the epoxy molecules to find the phosphoric acid, and I want all of the carbonate, the metal carbonate, the solid powder that's in here to find the phosphoric acid. We need those things to be in contact in order for the reaction to take place. So give me a second here while I mix it real good. All right. And this can also be done through a static mixer. So I'm going to show you another product where it is statically mixed instead of hand mixed. All right. And you can see I have this line here. Actually, the material is a little bit below the line. But as it foams up, it's going to rise above that line. So now this is an example of a static mixer. I'll show you on the camera here. It's hard to see, but there are these little folds. So as A and B pass through this static mixer, they're kind of folding on top of each other. And that is what mixes A and B together. So this is the same chemistry that I'm using. It's an epoxy side and an acid side. But you're going to see, because of the types of ingredients I added and how I process them, the foaming result is extremely different.
Anything going on over here? Not much, right? Not much. Kind of a slow reaction, right?
Mm-hmm.
Slow reaction.
So this, I added a little purple pigment to. And as it foams, it's going to appear like the color goes away. But what's actually happening is so much air is getting into the product that it just appears to lighten. The pigment is sort of diluted by all of the air.
What's happening?
You can see it happening now.
See a reaction going on? Happening pretty fast, right? That quick.
So in your volcano experiment with the baking soda and the vinegar, carbon dioxide gas certainly was produced, but it fell flat afterwards. The reason this is not falling flat is because we have cross-linking, a reaction that's happening that's holding the gas and trapping the gas and keeping it in place. So when this, it's still warm, because like I said, it's exothermic, so heat is being produced. Once it cools down, it's kind of like a packing peanut, you know, the things that you ship stuff in. It's real light and airy, and you can break it in half pretty easily. You know, not everything we make needs to be really strong, like the world's strongest bond. Some things need to just fill a cavity and support a stronger material, you know, that it's backing. It all depends on what the customer needs. So this one is still foaming a little bit. It's soft right now. I can stick my finger into it, but you can see it's risen up now to about just slightly above the line where we started. And after it cures, it's like that cylinder that this girl here is passing around. It's going to be a rigid material.
Hold up the one on that one.
Yeah, the one in your right hand.
Yeah.
Yep.
So remember how rigid, how hard did that get, right? Started out with a really soft material, turned into a cured material, cross-linked material, pretty strong.
Okay, so now let's.
Different chemistries can be used.
That this girl here is passing around. It's going to be a rigid material.
Hold up the one on that one.
Yep, the one in your right hand.
Yeah.
Yep.
So remember how rigid, how hard did that get, right? Started out with really soft materials, turned into a cured material, cross-linked material, pretty strong.
Okay, so now let's.
Different chemistries can be used for different things, right? Where can we use this? Right? Where can chemistry, where can science turn into solutions in the real world? These are some of the ones we are working on and have been for years, and just different things that we've come up with to solve world problems.
Yeah. So, in every F-150, America's most popular truck, has some of L&L's parts in it. And they're in this A-pillar here, they're down here. You don't see them because they're inside the cavity of the metal. There's some hollow parts in there because you don't want it filled with solid metal that's very heavy. It's going to reduce your gas mileage. But you need something in there to add some strength in the event of a crash. So, you've heard of the crash test dummies. They were in commercials for a while. But they crash cars and they put these dummies in them, and they want to see what's most important is what happens to the passengers in a vehicle. The vehicle's going to get destroyed, that's okay, but we want the people to be safe in there. So you can see without any inserts that this passenger compartment has gotten compressed. The dummy's knees are touching the dashboard. It's very close to the steering wheel now. But if we put the inserts containing our formulated, foamed, structural, thermoset adhesives in there, in that same crash test, you can see the passenger compartment is unchanged. This is what gives vehicles their 5-star crash test rating, or tests like these. This is why companies like Ford want to buy our parts, because they want to be able to offer a vehicle with a high crash rating, and this is how they're able to do that.
Mm-hmm. Are we changing the impact? Is chemistry making an impact on society? Yes, right? Saving lives. Starts out with a little experiment, turns into how can we use this? How can we solve a problem? And it's cars and products are being made different. They're inventing and next gen of things all the time. They're using different materials. We're not driving around in tanks anymore, right? We're driving around in cars that can crumple pretty. But with material science, you can give it properties that it may not have had with just welded metal together.
Mm-hmm. So L&L has been an auto parts supplier since 1958, but we're branching out now with our faster chemistry into do-it-yourself construction type adhesives. And this is what the material is that we hope some of you will want to work with us, to learn more about it, to learn how we make it, and to help us test it. We're not quite ready to give it to the construction field because we want to know maybe how it doesn't work or how it does work. We want you students to try it, to see if you can understand the instructions on it. And if you can't, we want you to help us rewrite it in a way that everybody can understand how to use it. We want you to hang something from it. See how much weight can you hang before it fails. So we're going to ask for your input on these. But this product here, you can't really see the product. It's called Fix and Fasten. So this is drywall. And if you have a party and somebody puts a hole in your parents' drywall, when you repair it, that repair typically is weak. What you can buy right now to repair it cannot hold a screw with a weight on it. It's a weak point in the drywall. You'd have to move whatever fixture point is off to the side. What L&L Products has developed is a material that when it fills a cavity, fills a void, is stronger than drywall. So you can put an anchor in it and you can hang a weight from it. And we really think this is something that's going to be useful for the construction application and people at their houses as well. The cylinder that she held up that I demoed for you, that is that rigid material, that is a concrete repair type product. So there were homes made in Connecticut that were made with bad foundations. So when the house was about 10 years old, which for a house is not very old, the foundations started to crumble and fall apart. There was a builder that had an idea. He said, okay, I can come in, I can jack up the houses. So they were kind of like up on stilts, sort of. It was a little precarious, but the builder knew how to do that. He tore out the foundation. He put in new composite foundations. But then he realized when he wanted to bring the house back down on the foundation, there were gaps some places. Some places it met the foundation, but it wasn't perfectly level. So they needed something that they could pump into those gaps that could fill the cavity, and that after it was cured, could hold the weight of the house. And that AK607 is stronger than brick or mortar. It absolutely can hold the weight of the house. And so L&L products solve this problem for them. And this is a product that is used in the construction industry for that and for other things as well. Give it back to Steve. He's going to tell you a little more about what we're going to ask from you.
Yeah, pretty exciting stuff. Hopefully you really liked Laura. She's excellent R&D formulator, chemist, technician, and comes up with a lot of creative things in her job. And so hey, what we're asking for, we have an opportunity where we can take education and we can take industry and what we're doing in industry and combine. And we're looking for a group of students curious that want to work with the L&L team and maybe have an interest in chemistry for a future career. Maybe you know nothing about chemistry. Like when I started at L&L, I knew nothing about it. Grew up on a farm, I knew nothing about it. I knew about tractors, I knew about plants, but I didn't know anything. But I knew something about equipment and putting things in. Well, it takes equipment. So we're looking for curious people that maybe you want to make things, break things, find out what properties are involved, test things. Maybe you want to learn what ingredients and what it costs to buy these things. It's all kinds of things. But we're looking for maybe a field in innovation, application, some hands-on work, some experimentation. What is the commitment? Well, 2 to 3 times you're going to be coming to L&L. You'd be viewing some demos. You're going to be more demos like this on the chemistry, more demos on equipment. You get to see scaled up equipment. What does it take to actually make some of these products in the real world? You're going to be making some applications, testing it. Wouldn't it be nice to, hey, you could take your teacher, let's see how much, could we hang them on the wall and see if it still holds? Well, some of these experiments fail. Maybe it can't, but maybe it can. Could we come up with something? Let's find out. Going to be doing experiments, mock-ups, evaluation with this new, faster technology. Okay? What is our learning goal? Well, learning goal is safely in the chemistry industry, experimentation, process scale-up, and application evaluation. Combination of theory and practicality. So yeah, you're going to learn about safety in a scaled-up environment. You're going to learn about experimentation. You guys use that scientific method, right? You've probably used it in your classroom. You use it when you're trying to figure out something. So with that, we have a QR code. If everybody in the class is going to be filling out just a little bit on the class. If you are interested in taking this a little farther and interested in what we're talking about, there's some more questions. Just say yes, and there's more questions. And then we're going to meet with this group and come up with something. Let your teacher know by the end of the week if you are interested too. You got to write a little description of why you'd be interested in something like this. It's 8 pages, just a small little quiz. No, I'm just kidding. I'm interested in something new, right? My next class, by the way, is Macbeth, right? I got to go to this Macbeth class and learn about tragedies. But, it's lifelong learning. It doesn't matter how much experience you have. You're learning something new every day. So going to something where, you get a lot of opportunities in this classroom of practical uses of science. Here's another opportunity. Take those opportunities. When you get a chance, come and learn something. And you can always apply it to your life skills, maybe to your career. So with that, this is the QR code. I think you'll be talking a little bit about what we want here and going from here. And I think everybody's going to be scanning it in. But with that, that's kind of, is there any questions? We'd like to probably open it up to questions about maybe the demos, about anything that someone might be interested in the field of chemistry. Anything at all. Who's the main character in Macbeth? No, I'm just joking. I'm not. I saw this and it reminded me of my high school. And I had to read this in high school 30, 40 something years ago. And it just reminded me of that, right? Because I didn't even know what the plot was, right? And now I read a little description of what the plot is and about, you know, maybe trying to create your own fate when maybe fate happens, right? Did I know that then? Did I know it was that simple, right? You just never know where fate will lead you, right? And be open to it. I worked, I got a degree in mechanical engineering and electrical engineering. I'm working in chemistry and compounding and putting equipment in different countries. Did I know I'd be doing that? No. So you just never know where fate will lead you. Little connection with that. So, yeah.
Thank you guys for coming in.
Thank you.
You guys might give them a round of applause there.